Hello, this is Rich, and today is going to be a tutorial on my first, just forget that. It's going to be an update on unit selection and movement done in C++. I know there's been a lot of C++ tutorials lately by me. I think there's been like 2, 3, and then like 1 or 2 updates on C++, and you guys probably wonder, wow, is this guy just doing C++ now, and what about all the other stuff? Well, it's coming. Don't worry about that. It will be there. It's just that I want to get the game mechanics down in my game first before I start any storyline, before I start any really the modeling, game design, designing levels. Before I get to any of that, I want to have my game mechanics down, how the game operates, my unit selection, my unit attacks, being able to select, being able to build places, that kind of stuff, those core game mechanics. And I've chosen to implement all that through C++, as it's the most advanced way of doing it and fastest way, because C++ is faster than all Lua and flowgraph. So yeah, this is going to be a few C++ tutorials, in the beginning here. So don't worry about that. But today's going to be a tutorial on unit selection and movement through C++, detecting mouse clicks, left click, right click, and also making your own custom flowgraph node. This is the flowgraph node specifically for my mouse entity that I'm making. But also, by doing this custom flowgraph node, you'll be able to make other flowgraphs. You'll see the process of making other flowgraphs that you want to create. So we're just going to basically just jump right into C++ here. My next tutorial is going to be, I probably won't have an update. On the next video. I'd rather have it be a tutorial, because I know I haven't done a really tutorial in a while. So what I'll do is do a tutorial here on C++ unit selection and movement, custom flow node for that. And the next tutorial is going to be integrating speech recognition into your game or project, and making a flow node for the speech recognition. So, I hope you guys are excited, and I've read a lot of your comments on suggestions on the RTS speech recognition, and I appreciate it. It gave me a lot of ideas. I've also been brainstorming here, writing down stuff on paper of how this stuff's going to work and make it the best. I really have really high hopes for this game. It's going to be a lot. In case you guys are wondering what type of game this is going to be, RTS game, right? But it's going to be like a, like a Civilization, Age of Empires type of game, where you basically start off you build these civilizations, you work on diplomacy with other people, or you can go and be enemies with other people. You can trade with other people. You can start wars. And you basically just try to dominate your world by either technologies, dominance over the land. It's going to be really, really advanced. It's going to be a lot of work put into it, and it's just me, so it's going to take a while, but it's going to be really great. Trust me, if you like those type of games. There's going to be a lot of strategy involved, and it'll be awesome. So that's the type of game I'm going for. So let me just jump right into the C++ here. And I got to remember the files that I changed, because there's going to be one file we're going to look at. I don't think we're going to change anything in it, but there's going to be one file we're going to look at that's not even part of this project. It's a Windows file that comes with the Windows that we're going to be looking at. I know this is glitching out on me, and then there's also something we're going to be changing in the game startup.cpp that we're going to need. I'm aware that there's other ways of implementing mouse detection through the Cry input system and action maps, but this was the easiest and fastest way to do it, and I'm going to show you how to do it that way. And what the hell are you doing, Microsoft? Come on. Those of you who have downloaded my source code to this RTS game here, it's not much, but it definitely gives you insight on what's in there, and you can fool around with it yourself and add to it. Those of you who have the source code, yeah, this is not working. Okay. Weird. For those of you who have the source code, we'll be able to see how because you guys might have, if you looked at it, you saw a mouse event function that I created that will take a mouse event. But you're like, okay, how do we know, how does this function get called? What part of the code calls this mouse event function? Well, this is what's in the game startup.cpp. You're adding stuff in here that will call that mouse function based on what you're clicking. I'm going to add a couple of operations in that game startup.cpp. This is weird. Wow. Alright, so we're going to open this up here. If you also have the code, you might not be able to run it, because you got to remember what I said in one of my tutorials. You got to go into your system.cfg, which is in your Cryengine root directory. It's a .cfg file, system.cfg, and you got to put in there sys underscore game underscore DLL or sysdll game equals RTS game, because it'll default to the cry game DLL file. In order to run my project, you need to have it run the RTS game, the DLL, and that's covered in another tutorial. Just waiting for internal operation to complete. If you regularly encounter this delay during normal usage, please report the problem to Microsoft. Alright, we're having issues here. This is crazy shit. Sorry, guys. This has never happened to me. I don't know what the hell's going on. I have no idea what the hell is going on. Whacking out. Are you going to be okay? Alright, good. It's all good. I don't know what the hell is happening there, guys. Sorry about that. So what we have here is we're going over the unit selection and movement, and I'll just go over my code here for that. And this is mainly going to be my RTS mouse.h, RTS mouse.cpp. You guys will have these. Well, you guys will if you have downloaded my source code. But if you don't have these, I'm going to assume you don't have the source code for these tutorials here. We're going to create one in the My Files filter I made. I also made a mouse filter. Inside of that, I right-click and I added new items, and I named these as RTS mouse.cpp and RTS mouse.h. And I went ahead and I created a class in the RTS mouse.h. Remember, typically when you're writing your declaration saying you're going to have something and this is its name and saying that you're going to use it, you typically do those in a .h file, a header file, and then you actually do the stuff it wants to do and define your variables and functions into a .cpp file. That's why I make two of the same name files, one .h, one .cpp. So the .h, we created a class, if you remember correctly. I talked about classes last time. We included the iHardware mouse because we're going to be accessing or defining functions in our class that are going to take use of the mouse interface, because we're doing stuff with the mouse. So go ahead and include the iHardware mouse header file. That way you can use those functions. And I created a struct called RTS mouse. You guys remember how to make those. Opening and then a closing with a semicolon. Don't forget that. Inside here I made a constructor, which whenever an object is made of, object or instance is made of the RTS mouse, it immediately runs the RTS mouse function here. So any initializations you have to do or variables you have to set right when the RTS mouse is used, go ahead and put all the info inside the opening and closing. Go ahead and, this is a definition, so declaration, so go ahead and define it You know, remember what defining is? Opening and then closing. In the .cpp, go ahead and write whatever you need to first do in the constructor. And then the deconstructor is when you're done using that, when it's done and destroys all those destroys all those objects or instances, and it's done. This destructor function is called, and it's the same name, but with this little symbol here, and you put whatever you want to destroy, everything you want to get rid of, any shut down things you want to do, you do it in this function here. That's why they're named the same name, because it's automatically called when it starts and then automatically called when it stops. When it's created and when it's destroyed. So I made my own functions here. I made a function void mouse event. Okay, this is my this is actually a pre-existing function here, and this function is located. Let me just right-click on. I don't think I can, but let me go to right-click and see. Find our references. See what this will happen. See what happens here. Yeah, probably wasn't smart to do that. Probably wasn't right to do that. So let me just tell you here, since I included the iHardware mouse, this function here is an overridden function, meaning it's an already existing function that gets called by Cryengine. It's a pre-existing Cryengine already did it, and I declared it in this class because instead of calling the other function, I wanted to call this function and do it here. So let me just go find iHardware mouse, and you can do that if you don't want to search and you've already included it in your project. You can just right-click on it, and then you can open the document. So it'll open up the iHardware mouse or whatever .h file you want to open. So let me go to the iHardware mouse class here, and let me go to its functions here, and there we go. Where the hell are you? Oh, right here. Okay. See this? Call that in your window process on Windows mouse move and Windows left button down and left button up. So I said, okay. So this already has detection of when the mouse moves, when the left button's down, and when the left button's up. What about right clicks, right up, right down, mouse, middle mouse click? So I already know that this function here, because of this code here, that it gets called. And apparently it's getting called from the Windows process, mouse move, blah, 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 blah. So I searched these keywords here by going to edit and quick find, and I look for these things to find out what other files have this word in it, so I can kind of find out where this is being called from, what file is being called. And what this is here is this event function is called, obviously, like I said, from whatever file is going to be detecting these movements here. And when it's called, we have the IX, and I'll explain this later, which is the X position of the mouse, Y position of the mouse, and then we have a, then we have an E-hardware mouse event enumeration, and E-hardware mouse event. When this function is called, it'll bring in the mouse X position, mouse Y position, the mouse event that happened, and what this is, it's if it was left clicked, it would bring in the left click enumeration. If it was right click enumeration. If the mouse was moved, it'd bring in the mouse move enumeration. And int wheel delta, I'm not sure what this is, but you don't need to bring this into a class, into a function, because it's already declared here. See, int wheel delta equals 0. So this is already defined here, so we don't even need to worry about this at all. But it is part of the function, so you're going to need that. So when I searched for all this stuff, I found out where Windows detects, where Cryengine detects all of its mouse input, and it did when it detected it in a file that had these things in here, obviously, because it's called on WinProcess on these things. So I searched, and where it came out actually was in the gamestartup.cpp. So let me go to the startup files over here and gamestartup.cpp. And let's go all the way here. We'll go to cgamestartup, okay? And then go to its functions here. Remember it said call this on your WinProcess thing? Well, I found that function, WinProcess. Window process, I believe that's what it is for Windows 32 API. But anyways, I look through here, and I see WM close. So when the window closes, do such and such. Mouse activates, do such and such. So I kept scrolling down, looking for the left mouse button down, left mouse button up, all that. And I found it. Oh, we have a, in case the Windows sends an event of set cursor, do this. In case the mouse moves, do this. And if you see here, when the mouse moves, it calls the function global environment p hardware mouse, which is a pointer to the iHardware mouse interface, right? P hardware mouse. Look at it. Hover over it. We got iHardware mouse as a return value. So it gets the this pointer here, gets the iHardware mouse interface. And then it calls the event X position, Y position of the mouse, and then it sends over the event. It was moved. Because it's detecting that it's moving, it sends over the enumeration that, hey, we moved. So when the mouse moves, it sends over all this info. It sends over the X position of the mouse, the Y position of the mouse, and also the event that happened. So when it calls this function, right, it calls the function, it sends over the X, that value is copied into this local X variable here for the function, it's copied into the Y variable for the function, and then the hardware event, it was moved, was into the function. So I said, okay, so I'm going to make my own class. I don't want to save that. I'm going to make my own class for a mouse. And now that I know where it calls the functions based on events, I'm going to tell it in that game startup that when it when the left button is down, okay, I'm going to make a pointer to my RTS mouse class, and then I'm going to tell it to call my mouse event. So if we go into my RTS mouse.cpp, I have my function RTS mouse event because it was declared in my RTS mouse.ac void mouse event, and then all the same info. And then in my RTS mouse.cpp, I defined it mouse event with blah 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 blah. So when Windows in the game startup, when Windows says, hey, the left mouse button was pushed down, go ahead and call the regular function that was already there, but also call my mouse function mouse event, and then send over its X position, Y position of the mouse, and then also this info. Okay, left button down. So see hardware mouse event left button down. So what happens is when that function gets, so if I left mouse button down, I told it to call my function mouse event, right? And this has now left mouse button down. This has the X and Y position of the mouse. And then I scroll down, and then I have case. Okay, case is another way of if statements, but you're just checking for specific type of things. And I'm saying I'm going to be testing everything against a hardware mouse event. That's what a switch is. A switch is when you say I'm going to have a whole bunch of cases, a whole bunch of possibilities of if statements, basically. If this, then do this. If this, then do this. This is what this is. Cases, if this, then do this. If this, then do this. If this, then do this. It's just another way of writing an if statement. So how you start this is if you go switch, and then the thing you want to test against. Meaning, let me write this out here. Let me just, I'm going to try to, okay. I'm just going to show you this here. If statements like this. If, and then a condition. If blah, blah, blah is true, right? Then do blah, 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 blah. So if whatever it is true, right? So on an if statement, the first and the second, they're compared against each other, and if they're true, then it go ahead and does the if statement. With the case, you put the condition somewhere else. The condition is in parentheses of the if statement here. While on a case, the condition is on a switch. So you go SWITCH, you get a switch, and then the switch is the condition. So we wanted to, okay, let's do this, make it a little bit easier. Cat. So, if the cat equals the cat, then do this. But on a switch statement, which is just like an if statement, but on a switch statement, you would just put one of those here. So we're going to have the cat. And that's the condition that every case is going to be checked against. So once I write that, I go ahead and I write case. And no cat, right? End it with the colon there, and then go ahead and do this. Case no cat, do blah 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 blah. Right? Case the cat, do blah 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 blah. So what happens is when you write a switch statement, which is just like an if statement, instead of the condition being in the parentheses here and then doing this, you write switch and then you write the condition here. And every case is going to be tested. So does no cat equal the cat? No. So it doesn't do this. Does the cat equal the cat? Then yes, do this. So that's what a switch statement is. You put every case is tested if it's equal to what's in this parentheses. So it goes over and says, okay, we have the cat. So this case, no cat, is going to be tested to see if it's equal to the cat. It's not, so don't do this. And then this case is it's the cat. It's going to be tested against this. Oh, they are equal, so go ahead and do this. That's what a switch statement is. Same thing as an if statement, just a different way of writing it. So now that we know how the switch statement works, we can sit around and continue with our thing. So the mouse event was called by Windows, and it sent over the mouse event, which in this case, the hardware mouse event was left mouse button down. And it goes down, and I'm saying switch, hardware mouse event. See, hardware mouse event. So this would be left mouse button down. See, left mouse button down. Because that's the event that happened, and that's what was sent over in this function. E hardware mouse event, E hardware mouse event. So this variable holds the left mouse button down. That's what's in this condition here, left mouse button down. So if our hardware mouse, case, hardware mouse event, left mouse button down, then do this. Well, in this particular instance, E hardware mouse event is the same as E hardware mouse event, left mouse button down. They are the same, so it does this. But in case the hardware mouse event left button up was done, then we go ahead and we do all of these. And in case the E hardware mouse event right button up, we do this. So that's all we did here. Is this function is called whenever Windows detects anything to do with the mouse happened, and then we told it to call our mouse event function. So when we call the mouse event function, we now have the X position of the mouse, the Y position of the mouse. I think that's what these are. We have the mouse event that happened, whether left mouse button was down or left mouse button was up, or any of those mouses moved. And then it does the function. Now we can use all of this info here. And we did. In this switch statement, we checked if E hardware mouse event left button up, left button down was the same as what we did. If so, we do this. Very, very simple. So now I gotta teach you about detecting more mouse inputs. Okay? Actually, let me just first go over the rest of the functions here. Have a function store entity ID under mouse. And this is my own function that I created. It's not a pre-existing function. It's an actual function that I created. And this will basically take the... first of all, we have a function that gets the entity ID of the entity that's under the mouse. And this function, we call this store entity ID under mouse to store that entity ID into a global variable. That way, flowgraph and everybody else can access it because it's global. I also made a function, get right-click 3D position, meaning when we right-click, it gets the X, Y, and Z position of the mouse. We need that. We have store right-click 3D position, which takes that right-click 3D position and stores into a global variable as well, so we can have the right-click 3D position. And this I'm not going over today because it's actually something I'm still in a work in progress for. I'm trying to get the units multiple, like I can select 10, 15 people at once and give them commands, multiple unit selection, because right now it's just one. But I'm working on, actually, I should have told you because I wanted to be surprised, but there we go. I'm working on creating multiple unit selection, but not just 1 and 2. So I'm not going to discuss that. And these are all part of my own multiple unit selection. And then we have a variable. Actually, no, a variable. Sorry, we have a function, get entity ID under mouse, which gets the entity ID under mouse. That's what it does. And it returns of type entity ID. So once it gets the entity that's under the mouse, it returns the entity ID of it, because that's the return value. And then we have a variable, entity ID under mouse, which is entity ID. This is a variable that holds the entity ID under mouse. You can pretty much see that this get entity ID under mouse, the return is assigned to this one. You can probably get that right away. Probably understand what that is. I created this function to get the entity ID, and I created this variable to hold the entity ID. So there we go. And we'll go ahead and we're going to discuss how to add more custom mouse input detection, because currently there's only the left mouse button stuff, and I have RTS game, you want right mouse button clicks as well. So let's go into here, and you're wondering, what are all of the hardware mouse events? Because we see left mouse button down is a hardware mouse event. Left mouse button down, okay. We have left mouse button up is a type of detection. We have left mouse button double click is a type of detection. So what are all of these mouse detections? What are they? What are all the possible events that each mouse can have? Well, all you'd have to do is, this is a enumeration that Cryengine had, and enumeration is like a list of data, basically. So let's right-click, and let's go to definition to find out where this stuff is coming from. Where is all this stuff defined? How can I find all of the mouse events that could happen?
Jose, you took pictures with Nana's camera, right? Yeah. None of the pictures were on her camera. Nana, did you have a memory card?
Hold on, guys. So one thing you'll find is that if you don't have my source code, some of these options won't be here. So Cryengine already had functions for when the mouse moves. Cryengine already had functions when the left mouse button was down, when the left mouse button was up, when the left mouse button was double click. They did not have when the right mouse button was down, when the right mouse button was up, when the right mouse button was double clicked. I don't think they had these. The right buttons once. Okay? They didn't. So this is where Cryengine says, okay, these are the different events that a mouse can have. And I found out more because I really wanted to find out how to do the right clicks. So that was important to me. So I'd use my very friendly tool, which you guys will be using quite a bit because it's unbelievably awesome. It's the quick find. That is edit quick find. I don't know why my computer's being so slow. Come on. Okay. And we will look for this. Actually, all right, stop. It goes like this. I made a text file that told me, why is this going so slow? Sorry about this, guys. And like I said, this is the basic explanation. My formatting I do on my videos. This is the basic. We'll go into detail. Come on. What the fuck is going on here? And this is what it comes down to. I wrote a note, gamestartup.cpp, that's why I don't forget. Gamestartup.cpp has handling of the mouse detection, meaning it calls functions based on what events. But the gamestartup.cpp doesn't have all of the mouse detections because Cryengine can only see the ones that are here. And some of these weren't even there to begin with. So I had to find a way how do I add this? So I kept searching. And I found a winuser.h header file. And this has the mouse detection, all the different types of mouse detection that a Windows application can have. So winuser.h. And a cool way to find out these files, because this file is not part of this project, I don't believe. The easy way to do that is type in pound include. Here's a little trick that I came up with myself. Pound include winuser.h. And I've just got done including that. Then all I do now is I right click and I open up the document. There we go. It finds it for me. I don't want this here because it'll screw it up. So let me just go ahead and delete that. But so I scrolled down here and I kept going. And let me search. Okay. And look at this. I found the definitions here. We have WM, right button up. Windows will detect this, but Cryengine didn't include this in their mouse detection. They didn't. So I searched and I found some. Right button up. And I just found this, guys. And what's the magic way of finding? How'd you find it? I spend too much time in Cryengine C++ just searching around. And I use this quick find feature by searching for everything that will possibly I think will give me results. And I ended up just stumbling upon this. And I found all of this info here. So we have mouse move that Cryengine already had. We had left button down, button up, blah, 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 blah. Right? Alright. So now what happens is, since we know that we have detection for the right mouse button down, right mouse button up, right mouse button double click, I just copied these WM blah blah blah, WM blah blah blah, WM blah blah. I copied these, and I put them as part of the enumeration. See? I put them. Well, I changed the naming convention. I put eHarbor mouse event before it, and then what it was. So I just took the here, all right button down, and I put this before it as part of the enumeration, just like that. So now we officially have detection of, so-and-so, of different types of movement. So now we have different detection of mouse clicks and stuff like that. Since we do, in the game startup, it handles all of that. So what I did was this case WM right mouse button down. Hold on. See this here? You see this here? WM, right mouse button up. That's a Windows thing. Now, it's very... Oh, crap. I made a mistake here. Pound include win user .h. Let me open this up again. I just want to make this very clear. Oh, great. Oh, freaking great. I gotta find it again. God damn it. Oh, I'm close. Okay. These things are here on WinUser.h. This is not part of the CryEngine project. This file here is actually for just Windows in general, your Windows operating system. And these are things that Windows itself, CryEngine doesn't detect these really. It's the actual Windows application. It's Windows that detects these movements. That's these click events and the mouse events. It's Windows that does this, not CryEngine. So we have WM right button up and right button down, WMs, right? So in this game startup.cpp, we have a Windows process event, which is in every it's in every Windows 32 application, Windows process event. And Windows is what basically takes this info and it detects these different types of input. So right now, Windows is going to say, okay, we received some sort of event. Now, what event was it? Was it case sys key down? Was it set cursor? Was it Windows the mouse move? Was the left mouse button down? Okay, so there we go. And the WM right, all the right button stuff didn't exist. WM right button up, WM right button down, WM right button double click. These did not exist at all. So I just followed the formatting. I just basically copied one of the other ones, just like this. I took from the case to the return, WM, left button up. I copied it, and then I just pasted it right after. I replaced it with our hardware event. In this case, it was WM right button up, using the right button up here, using that event here. I made my own. In case Windows detected that the right mouse button was pressed, I just did my own function. I told it, if it detected that the right button up was done, go ahead, create a pointer to my class, then take that class and run its own function called mouse event. Remember, I took my class and I have a mouse event function. Go ahead and do that. So that's what I did. That's all I did. I found out the different types of mouse events that can happen, and that was located in the WinUser.h, not part of the Crytek project, the CryEngine project. It's part of Windows itself. Windows detects these things itself by default. Windows does this. So I found it, and this is also a Windows function, a Windows API, Windows 32 API function. The L result callback, Windows process. You'll find that in every single Windows 32 application. Crytek decided just to extend from it. They basically extended from the Windows 32 class and made their own C-Game startup Windows process. Same thing. It's the same as in Windows. Windows will detect all this stuff. Case is this, then do this. Case is this, then do this. Case is this, then do this. And I just put case left WM right button down, do this. Okay? Case right button up, do this. So I just added in my own cases. Added in my own cases. Telling it to call my own function. Added in my own cases, telling it to run my own function. Left mouse button up, made a pointer, and then told it to run my own function mouse event. So whenever a mouse event is detected, I told it to call my function and send over the mouse event that it detects. So that is how you get Windows to detect your mouse events, by adding in, on the game startup, adding in your things here. Adding in your things here. And when we call the function, here's the thing. We're sending over the parameter. In this case, it's hardware mouse event left mouse button up. If you remember, in the iHardware mouse file, CryEngine's own file, they made their own enumerations. eHardware mouse event, eHardware mouse event, eHardware mouse event for all of these. So when I called my phone, I made Windows' own enumeration here, or definition here. When that happens, go ahead and call my function and send over the hardware mouse event left button up. Because the left button up happened, go ahead and send over the left button up event. There we go. Very simple. I'm not sure if I did a great job of explaining it, but that's the best I'm going to be able to do. I basically added more cases to the Windows process event, more case statements to the Windows process event, which is in game startup to CPP, on the different types of events that Windows can detect. In this case, I added the right button up, right button down, right button double click. On the existing ones, left mouse button up, left down, I added just to call my own functions. That's how you do it. That's how you get CryEngine to recognize your input. And then you got to create a function, because you're telling it to run a function when it detects that that input was pressed. So when this input was pressed, go ahead and run my mouse event function. So it does. It runs my mouse event function. Blah, 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 blah. And then I check. Was it the left mouse button that was pressed? Yeah, do it. Was the left mouse button up? No, so don't do it. Was the right button up that was pressed? No, don't do it. So that's what that is. That's how you get it to have your input be detected and then run a function off based on that input. So now that we have basic input detection by doing what you saw there, okay? Don't need these anymore. Let's go ahead. Since I have my function RTS mouse and the mouse event, let's go ahead and go over. We're going to go over these one by one. Okay? Actually, probably not. We're probably going to go into them in a sense that makes sense in order. What order makes sense. So we're going to start with the mouse event function. So we know that whenever a mouse is pressed, it gets the input and then it runs functions based off of what mouse event. We saw that in the game startup.cpp. Whenever a mouse event was received, it was told to run a function. In this case, we told it to run our function as part of our class. We did. So at the start of this, I created. You can look at these hints too if you want that I wrote. But we create a iEntity, pEntity. So we create a pointer pEntity of type iEntity, which is going to, in the future in this part, is going to hold an entity that we get, because it needs to be of type entity. If we want to store entity, we need to have a variable of type iEntity. So we do that here. Then we have a hit position variable, which is a vector3. We have a vector3, a variable named hit position. And then we're going to be using RTS mouse functions and RTS camera functions. So I go ahead and I create, because remember I had an RTS mouse class and an RTS camera class. Before everything's going through, I go ahead and I create an object of RTS mouse called RTS mouse 01 so I can use its functions. Then I also create a RTS camera 01 object of RTS camera. That way I can use my camera functions. So by doing these two here, I create an object and an object of RTS mouse class and an object of RTS camera class. This is so that during this mouse event function, I can run my camera and mouse functions. And this is one of the examples. I don't want to detect any mouse input until my level is loaded. Until I'm actually in my game, I don't want to detect any movement whatsoever or any input whatsoever that I've made custom. So first, I check string current level name equals RTS camera 01. See, I wouldn't be able to call my get level name function as part of the class unless I created a object. So I did. So what I did was I made a string variable called current level name, which holds string, text, equals RTS camera 01 dot get level name. This get level name function is something of my own creation. I created it. And hover over it. You can see the return type is string. So what happens is string current level name equals RTS camera 01 dot get level name. It goes ahead and it runs the get level name function, which gets the level name, and then the return value, which is string, is assigned to the current level name. So at this line right here, current level name will equal the current level's name, because we told it it's going to equal the return value of get level name. Every function, you can tell it to return a value if you want. In this case, this get level name function I created returns a value. And the value is stored, see, equal, is stored into current level name. So let's go over this get level name function so we know exactly what this is all about. Because you're going to need to know how to create it if you want to do what I'm doing. Because I don't want to do any mouse detection unless we have a current level loaded. And that is located, if you have the source files, it's located in cameras, RTS camera, rtscamera.cpp. We have a string, and let's open up the .h file as well. So in our RTS camera, we had a function, string get level name. We declared it. See, we declared a function get level name that's going to have a return type of string. And then the RTS camera.cpp, we have a definition which says this is what the function does. Okay? We have, when this function runs, so we call it, hey, get level name. We did that already. So this is what it does. MP game framework equals global environment pgame get iGame framework. So this is already an existing function that basically returns the game framework. So the game framework is now put into this pointer MP game framework. Oh, by the way, it's a member variable. So if we go to the class of RTS camera, see, we have a pointer MP game framework of type iGame framework, because the iGame framework is going to be returned into this value. We need to have it of type iGame framework. So we made of type iGame framework here, RTS camera. So we just use it here. We have the MP game framework pointer, and that's going to equal the iGame framework. So string level name equals MP game framework get level name. So Cryengine has its own function called get level name, and it's part of the iGame framework class. So if we look at the iGame framework class, we're going to see it has a function get level name, and that gets the name of the level that's loaded. You know what I'm saying? So we create a pointer, MP game framework that equals the game framework. Then we say, hey MP game framework, go ahead and use your function get level name. Take the return type, which is a constant character, which is a string, and put in level name. So now our level name has, the variable level name has the actual name of the level that's in the variable. So the name of the level that's in the variable. Okay, so we use Cryengine's own function from the iGame framework, get level name, and we put the value of that into level name. So now this level name variable holds the name of the level in string form. Then we say, oh, we're all done, we got the level, let's return. What are we going to return? We're going to return level name, so that when we go back to where we called the function, we're going to have the value level name. So here we go. We made a string, current level name, which is a variable, it's going to hold a string, and it equals get level name. But remember, when we got this level name function, when we did this function, it got the level name and it returned the level name. So that level name is being put into current level name. So here we go. Then we check if. If current level name, which is the name of the level, does not equal blank, then go ahead and do everything. Everything. Okay? That's what it does. So, what does this mean? If it does not equal blank, that means it has something. Meaning, if your level has a name, then obviously your level's loaded because it got its name. But if your level wasn't loaded, how could it get your name if it didn't even have a level loaded? It can't. It can't get your level's name if it's not even loaded. So this is how we check if the level is loaded or not. We say, if this current level has a name, then do everything. But if it's blank, if there's nothing in it, then don't do anything. So all these steps in here will not happen if there's no level loaded. So now that we know that, we say, okay, there is a level loaded. Now, we check for the mouse events. So there's a level loaded, so go ahead and check for the mouse events. Switch hardware mouse event. See, we're comparing everything to what event happened. In case it was hardware mouse event left button down, right? We do this. In case the event was left mouse button up, we do all of this. In case it was right button up, we do all of this. And then this default, which is a case as well, default, with the colon here, means that if none of these are true, if there was a mouse event and none of these were true, then it would automatically do the default. And we don't have anything for it doesn't do anything, see? Default break. Doesn't do anything. So we have nothing for the default action. But that's what default is for. Default in a switch statement means that if none of these cases are true, then go ahead and just do whatever the default. But we don't have nothing there. That's fine. Because we only want to do stuff if there was something detected, not if nothing was. So that is how we do stuff based on which mouse button we pressed. So let's go over each of these. So now that we know how to do something when a certain mouse button was pressed, let's go over what these actually do. Now stay with me, because as these tutorials go on, they get more complex and more complex. It's just natural. That's how they have to go. So by now you guys may be confused, maybe not. But it's going to have to be that way, because as you get more complicated concepts in your game, you're going to have to be more. It's going to be a little bit more complicated. All right. Okay. So, I've decided that when I press the left mouse button, okay, so when I press the left mouse button, I decided that I want to get the, I want to select things. So when the left mouse button is pressed, what about a regular RTS game? In a regular RTS game, when you left mouse button, it selects, right? When you click the left mouse button, it selects. So that's what I want to do. When we press the left mouse button, we want to select things. That's exactly what we want to do. We want to select things. So that's what I've done. I've implemented a selecting system inside the left mouse button event. So when we left click, we're going to select things. How do we select things? First of all, ignore all of these. This is for multiple selection. Okay? This is for multiple selection. We're not going over that today. But I'll go over the things that we are doing. Global environment, plog, log, left mouse button was pressed. So it's just a logging feature. When we press the left mouse button, I'm going to print out to the console, left mouse button was pressed. Very simple. Global environment is pointing to the plog interface, and we're going to call its function log. And what is it going to log? A string called left mouse button was pressed. So when we press the left mouse button, I want it to say, hey, log to the console, left mouse button was pressed. That way I know it was pressed and this code was run. Okay? There we go. That's when the left mouse button's down. And whoopsies, I made a mistake. On the left mouse button down, we're not selecting things. My bad. So we don't even need to go over that at all. This is nothing, that you need to worry about. Anyways, when we left mouse button up, meaning when we click, and then when we release, it does this. Okay? When we release, it does this. Okay? Jesus. Okay, so when we release, we want to implement a selecting system. So we log, left mouse button was released. Okay, don't worry about this at all. Okay, here we go. So when we left click, this is for single unit selection. Don't pay attention to any of these things. Only pay attention to what I described to you for the single unit selection. Besides, this code won't work anyways. It's not fully implemented. So when left mouse button was up, when we release it, we want to select things. So we log, left mouse button was released, and then we call a function, RTS mouse. Remember, we call a function that's located in our RTS mouse class. We have its variable. We have the variable m entity ID under mouse. So in our RTS mouse, we have a variable. RTS mouse class, we have a variable called m entity ID under mouse. What's that going to equal? It's going to equal the return value of this function that we created. And we're going to go over that. So when the left mouse button was pressed, released, we log left mouse button was released. Then we run a function that gets the entity ID under mouse. We get the entity ID of the mouse. When we left click, we want to get the entity ID that's where we clicked. And so we go ahead and we run the function that's part of our RTS mouse class, get entity ID under mouse. So we go down, we go down, we go down. Let's find it. Get entity ID under mouse. So this function is run. So when we left click, when we release the left mouse button, we want to select things. So we log, left mouse button was released. Then we call the function get entity ID under the mouse because we want to get the entity. We want to select things that are underneath the mouse when we click. And I can't really explain this, guys. I'm sorry. I can do the best that I can. I really can't. This was taken off of the CryDev site, CryWiki, I should say, CryWiki from the CryDev site, and I don't fully understand, so I don't really feel comfortable explaining all this. You can literally, you can literally copy and paste. Actually, the best idea is just download my source code. You'll have this in there. But I'll try my best. So when we get the entity ID of the mouse, this is how we do it. We make a variable of type, call variable hit. Sorry, not variable. We create an object hit of type ray hit. We have variables of type float, x, y, x mouse, y mouse, z mouse. Okay, and we give them all a value of 0. X is the screen space left. X right here is going to be holding the mouse's X position and screen space, as in just your screen. Y is going to be holding the Y position of just the mouse. X mouse is going to be holding the 3D position of your X's mouse position. Y mouse is going to be holding the 3D position of the Y. Z is going to be holding the 3D position of the Z. And we give those a default value of 0. And this checks first if not, P hardware mouse, and this sign here is an OR, means OR. So if we don't have any of these, so if any of these are not true, which I don't really understand, if any of these are not true, go ahead and return. Then we create a P client actor pointer of type iActor, and we assign it to get client actor. So we basically tell the engine to get us, get who we are, and then assign it to the client actor. And if we don't have a client actor, if we don't have it, then just stop the function and return to where it was called. And this gets the mouse's X position and Y position. And unlike other functions that when you say get hardware mouse client position, it doesn't return any value. And this is something that's different that I recently learned about, but it's different. Usually I'm used to calling a function and then taking the return value of that function and putting it into a variable. This doesn't work that way. We have a variable called X and a variable called Y. And this is the X's screen space, Y screen space of the mouse. So this gets the hardware mouse client position. And we're telling it, hey, send these values over. And I would expect that it would return the mouse's X and Y position. We can put that into a value, a variable. We can't. This does the same essential thing. It just does it a different way. So we're not sending over the X value or the Y value. We're sending over the memory address of the X value and the memory address of the Y value. And I'm guessing inside the get hardware client mouse position function, it changes the values of the inside these addresses. So what happens is, even though we're not getting a return value being assigned to a variable, this function is going to change the X and Y variables here. They're going to change their values. So you're not going to have to return and store your value into any variable. This function here will take the addresses of these, and I'm guessing inside that function that runs, it changes these values. So X and Y, the values of X and Y after this function is no longer going to be 0. They're actually changed with the actual X's mouse position and the Y mouse position. It's really weird, but that's what it's doing. Is it's not returning the value of the X and Y's position. You're giving it two variables to change so that it can store it in the already existing X and Y. And then we say Y equals, which is the mouse's Y position, equals. You're taking the renderer, you're taking the iRenderer, the interface of the renderer, and we're getting the height. Getting the height of function of the renderer system, meaning you're getting the height of your screen. So if I have a 1920 by 1080 resolution, it's going to return 1080 because it gets the height of the screen. So it's 1080. So because this is done before the value is assigned, it doesn't use the Y value. It's saying we're getting the height, okay, which is, let's say, 1080, and we're minusing the value of the Y that we got here, so our Y here, and then we're going to put that into Y. So Y will have a new value of where your mouse is. I think it's a little bit of correction done on the Y mouse position to get the actual position. Like I said, I can't explain this well, guys. I really don't understand it fully. I'm very sorry. This global environment P renderer unproject from screen, and I just recently learned about this. I'm not quite sure, but What this does is unproject from screen, meaning it takes your screen space things, the screen space values, and put them into 3D values, X, Y, and Z. That's what it does. So we're taking the screen space of the mouse's X position, screen space of the mouse's Y position, screen space of the mouse's Z position, which is 0, because we're not talking about Z position now, because we're just talking about the screen. And the first 3 parameters are the ones you want, the screen space. The next 3 parameters means these values, okay, the screen space values are going to be put into these values, but they're actually going to be converted to 3D positions. It's weird. I'm not used to functions not returning values like that. This function actually takes 6 parameters. The first 3 are the screen space. Inside of this function, I think that inside of this function, it takes those first 3 parameters, converts them to 3D coordinates, and then puts them into these variables. So now that your X mouse, X, Y, and your X mouse, your Y mouse, and your Z mouse will now equal your 3D positions of your actual mouse. So you got your screen space positions, and through a couple of functions here, we turned it into 3D positions. So we have the mouse's 3D X position, the mouse's 3D Y position, and the mouse's 3D Z position. So we have static constant unsigned int flags. This is a variable here called flags, and it's going to equal to enumerations, RWI stop at pierceable, RWI collide type any. We're going to be using those in a few minutes. Then we have fRange, which is a type float, and it's going to equal the max view distance. So your engine's max view distance is going to be put into a variable called fRange. The vCamera position, which is of type vector3, X, Y, and Z. vCam position is going to equal, it's going to get your camera's 3D position, because we're going to call the P system. Get view camera, so we're going to be able to get the current camera that we're using, and then we're going to get the current camera's view position, get its position. So the V camera position is going to hold the vector3 values of your camera's position. V direction is going to equal your mouse's X, Y, and Z position minus your camera's position, and then it's going to get a normalized value. So it's going to get the value of the X, Y, and Z mouse position, 3D positions, minus the V camera position, so that's going to be a value here, and then it's going to get the normalized version of that value. And then we're going to create a pointer of type iPhysical called pPhysical, and that's going to equal our pClientActor get iEntity. And this question mark here is a very, 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 very simplified way of writing an if statement, if I'm correct. It's a very simplified way of writing an if statement, meaning if there is a... so this is going to take our who we are, and we're going to get our entity. If this is true, if this evaluates to true, then go ahead and do this. If this evaluates to false, go ahead and do what's after the colon, null. So the physical entity is going to equal, if there's a client actor, if there is, we actually are in the game, if we are there, if we return true, then physical entity is going to equal our physics of us, who we are. If there is no client entity at all, physical entity is going to equal null. There's not going to be a physical entity. And if there's not a physical entity, then go ahead and stop the function and return where we came. Don't continue. This right here runs a ray scan, which you might be familiar with the mouse entity in the flow graph, where you can tell it to perform a ray scan, or a physics ray scan. It performs a ray scan, raycast I should say, and global environment physics world, blah 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 blah, and it causes a ray scan. Ray world intersection is the name of the function that's part of the physics world class. And when you call this function, it's going to take the parameters. It's going to take the camera's position, the direction, what type of entities the ray scan is allowed to hit. In this case, it's allowed to hit all. It's enumeration. All. There's certain flags, and the flags, if you remember, are it's going to stop at pierceable and it's going to collide with any. Hit. is going to store a whole bunch of information about the hit, like its position, the entity that was collided with it, and that's all. So if we perform the ray scan, then there's if we perform a ray scan, it's going to find if there was a physical entity, and it's going to hit collider. See, hit.collider, that's this right here. It holds information. So since hit is actually a object, we have the dot operator, dot resolution that we can use. So we have a class of type hit, dot p collider, and this variable p collider that belongs to the class of hit. This equals what the raycast collided with. That's what I was saying with the hit held a whole bunch of information. So basically, it's going to get the entity from its physical form, the actual entity. Okay, and then if there is one, it's going to go ahead and get the entity ID. It's going to return entity ID. So now we've done this. We return the entity ID of the entity that it hit. We're going to return, and here we go. So our M entity ID under mouse is going to equal the return value of the function. In that case, the return value was the entity ID. So the entity ID of the thing that was hit is now in the variable M entity ID under mouse. So now our variable here holds the entity ID that was under the mouse. Skip all this, and we're just going to do this. This is single unit selection, remember. So after we got that variable, we're going to call a function that we created, RTS mouse, right? Store entity ID under mouse, which is something that I created, which takes that local variable, because this variable is local here. It's not accessible through everywhere in the scripts, and we want this variable to be accessible from everywhere because we're going to need it in flowgraph in a different C++ file, so we're going to need to make it global. So I made a function that takes that local variable and puts it into a global variable so anybody can do it. So RTS mouse 01 store entity ID under mouse, and then it sends over the entity ID, that variable. So it sends it over. It says, okay, we're going to store the entity ID under the mouse function, and we're going to send over the entity ID under mouse. So let's go down. Store entity ID under mouse, so it does it, and it takes unsigned int. So we send over the entity ID. We were going to copy that value into the variable mouse entity ID, mouse entity, so that we can use it in our function. And then we made a global function, a global variable, in the globals.cpp and .h file. So in the globals.h file, I have my declarations of global variables, and we have an extern, because you have to say in the .h file, it's extern, meaning this variable is going to be defined somewhere else, because right now we're just declaring it. So we got the extern. It's going to be a type unsigned int, and it's going to be called G entity ID under mouse. And .cpp file, we don't have the extern. We just redo it. Here, unsigned int. Everything is exactly the same except you don't include the extern. Unsigned int G entity ID mouse equals 0. We have to give it a default value. You have to give these global variables default value, and I put 0. Since we have that global variable, we say, hey, the global variable entity ID under mouse equals our mouse entity. So basically, the entity ID under the mouse that we got was put into mouse entity because we sent it over in an argument. And now we say that that entity is now put into the variable G entity ID under mouse. So now we now have a way of referring to that entity ID that we selected by using the G entity ID under mouse. So let's go over this. I know it's confusing, guys. So if the left mouse button was up, we log, left mouse button was released. Then we run a function, get entity ID in the mouse, which performs ray scans to get the entity ID in the mouse, and it returns it into our member variable here, M entity ID in the mouse. Then we call a function store entity ID in the mouse so that we can store our member variable into a global variable that we created here. So now that global variable holds the entity ID under the mouse. So there we go. We just selected something. When the left mouse button was up, we said, hey, get the entity ID under the mouse, and then store its identification, store who he is into a global variable so that we can use him to do stuff. So he's, he's selected. He's selected because we have him in the variable, and we could tell him to do stuff by referring to that variable. Pretty cool. That's single unit selection. Single unit selection was only in here, left mouse button up. That's all you need to concern yourself with this throw. So we just basically selected somebody. So now that we have some selection going on, we selected the guy because we stored him into a global variable that we can use to tell him to do stuff, tell him to go somewhere, because we could just refer to that global variable as him. Now that we've got him under our memory, he's in our memory, we know we can have him, we can use him to whatever we want. Now we have to do something with them. We have him selected, so let's move him. Right? When we right-click, let's go ahead and move him. So when we right-click, let's go ahead and move him. So when we right mouse button is up, when we right-click, when the mouse is released, we log right mouse button was released. Okay, ready? Because I don't want to move anything. I don't want to move anything at all if there's no entity in our memory. So I'm saying if the G entity at the end of the mouse equals 0, don't do this at all. Don't do it. But if G entity at the end of the mouse does not equal 0, meaning there's obviously something in there because it's not 0, then go ahead and do this. So when our right mouse button is pressed, released, we log right mouse button was released. Then we check, okay, is there some? Do we have an entity in our memory? Is there some? Do we have anything selected? If we do, then go ahead and do this. And this is what we do. Look at this note. Store the hit position of the raycast to a variable named hit position. Hit position is a variable, vector3. Vector3 hit position. Remember, you saw that way up here. I declared it up here because of scope. Since I declared it before anything down here happened, I'm able to use it. So let's go ahead. So vector3 hit position equals RTS mouse 01 dot get right click 3D position. So I made a function, get right click 3D position, because when I right click, right, I want to get the position of my right click so that I could tell my guy to go to that position. Right? So I want to get the right-click position so that I can tell my guy later on to go to that right-click position. So that's what I do. I have hit position is going to equal the mouse's right-click 3D position. So I go ahead and I call this function, I get right-click 3D position, and RTS mouse, get right-click 3D position. It's the exact same thing as this. The entity ID under mouse is pretty much the same thing, just copied here. Okay? The only difference is, okay, I commented out, if not P client actor, I commented that out, return 0, I commented that out. I commented out, if not a physical entity, return 0, I commented that out. And I commented the if statement up here. If get entity from physics, blah, 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 blah. I commented that out. So I have if, which is here. This is performance array scan. So this is going to perform a array scan, right? And then after it's done the array scan, it's going to return hit.pt. See, we have the information about the hit. Well, hit.pt, you have to write pt. It's actually, something that, it's not something I made up. It's actually existing in that class, pt. pt means the position. It means a 3D position that the ray hit. So when we right-click, we're going to perform do all this. We're going to perform the ray scan, where we right-clicked, and then we're going to return the position. Return the hit.position. Okay? We're going to return the hit.position. We're going to return the position of our right-click 3D, our right-click mouse position. Very simple. So now that we have the right-click 3D position, just remember, even though these are basically the same, this returns the entity ID, so that's the return value. This returns the vector3 3D position, so instead of entity ID, we make it of type vector3. Got it? That's great. So that's vector 3 because it returns a vector 3 value, x, y, and z. So now that we performed the array scan and it hit something, the terrain, or hopefully it hit the terrain, it returns a 3D position. So it turns a 3D position. 3D position, so that vector 3 3D position is stored into our vector 3 variable hit position. So now our hit position variable of type vector 3 now holds a 3D position of where we right clicked. Okay, because we want to, when we right click, we want to take the guy we have selected and we want to move him to the position. In order to move him to that right click position, we need to know what position it was. So that's what we did. We got the right click 3D position and we put it into a hit position variable that we made. Now, you may have seen in my RTS update that I was not able to make the AI go to the 3D position. I was not able to make that entity go to that 3D position in C++. That's something I couldn't do. That's why I said, okay, I'm going to have to make a flow node. But before I do that, we have RTS mouse01 store right-click 3D position. And we tell it to say, hey, bring over the hit position variable so that we can use it. So that's the thing. We got the right-click 3D position, and this is a global, local variable hit position, so we can't use it in a flow graph or anything because it's local. It only has local scope. Can't use it in other .cpp files. So we store it. We get around that by storing it into a global variable. So I created another function called store right-click 3D position, and I bring over that hit position variable here. So let's go ahead to store right-click 3D position. Store right-click 3D position, and it's going to take in a vector 3 because that's what we're sending over. We're sending over a vector 3 hit position variable, so we need this argument here, parameter 1, to be a vector 3 because it's going to take in that vector 3 position. So we have vector 3, mouse position 3D. So mouse position 3D, obviously we talked about arguments in my last tutorial. Mouse position 3D is going to equal the same as what we sent over. So we called this function, we called store right-click 3D position and sent over our vector 3 hit position. That was parameter 1. So on the receiving end, the store right-click 3D position definition, it copies that variable into the mouse position 3D. So now this mouse position 3D variable equals our 3D right-click position. So we store that into our global variable, G for global, let me know that it's global, so I don't screw with it, because having global variables is kind of dangerous. But that's why I put G, so I know, it's very strict in what I can do with it. I don't want to mess it up. So I take that mouse 3D position, and I right-click, and I assign it to a global variable, G right-click 3D position. And this is done the same. It's a type of vector 3, obviously, because I'm putting a vector 3 value into a vector 3 variable. So making that global variable, same. I have a globals.h and globals.cpp, where I make all my globals. Extern in my .h, we're declaring. Extern means this is going to be defined somewhere else in the file, somewhere else in the program. Vector 3, the type, and G right-click 3D position. And then in the globals.cpp, we define it with the default value, because you have to have a default value. And we have vector 3, because you don't include the extern when you're defining. So vector 3, G right-click 3D position, equals 0. Because you can't put 0, see 0 here, you can't put that on a vector 3 because vector 3 takes 3 values, an x, y, and a z. And obviously, 0 is only one value. But thankfully, Cryengine made an enumeration of type 0. Enumeration 0, which represents 0, 0, 0, x0, y0, z0. So we just put in 0, which means x0, y0, z0. So it's a way of putting 0 for default value. So now we got the right-click 3D position put into a global variable. Now we're ready to do something. We have the entity selected, and we have a right-click 3D position. All we need to do now is we need to make the entity go to that 3D position. Cool. And that's where flowgraph comes in. Hold on, guys. That's where flowgraph comes in. Let me just close out all this. Okay. So I created under my files, filter. I created a flowgraph filter, and then nodes inside there. And I made a mouse entity node.cpp by right-clicking on the nodes, add new item, mouse entity node.cpp. So let me just open that up. You don't need a .h on this, actually. You just need the CPP file. It's pretty cool. Flowgraph, I'm still kind of learning the ins and outs of it, so I may not be able to explain it to its fullest, but I can do my best job. I think I'll do a pretty good job on it. So we include std.afx because in CryEngine, every .cpp file needs to include the std.afx.h. And on flowgraph, this is what you need to include. You need to include the g2 flowbase node.h. You need it. G2 flowbase node. You need to include it. You may not have all of this junk behind it, but because where I stored this mouse entity file, I needed to tell it its position. So all you need to know is you need to effectively include this G2 flowbase node, okay? And that's located in nodes G2 flowbase node, okay? Include globals.h because I'm going to be needing my person I have selected and the person in the 3D position that I right-clicked on. So I need to include those because, you know, these values are stored here. You know what I'm saying? These values are stored in the globals. So I included the globals.h so I can access my global variables with their values, the entity it's selected and the 3D position I clicked on. So in order to do this, you need to create your own class based off of the C flowbase node, and it needs to be of type ENC instance. There's other types, but we're just going over the instance type right now. So you need to make a class, not struct. Make it a class and name it whatever you want. Whatever you want, whatever suits your fancy. So I name mine C flow mouse entity, colon, because we're deriving. We're saying that most of this class is going to have, most of the class stuff is already done in C flowbase node. So C flowbase node here is a class that already has a lot of stuff done for you. So what deriving is, you're making a new class that's going to include all of the stuff that they've already done for you. So it just makes your work a lot easier on making flowgraph nodes. So make a class, named whatever you want. Make sure you have a colon. This means you're going to be including, deriving. And you're going to write public C flowbase node. So your class of C flow mouse entity is going to be derived from C flowbase node ENC T underscore instance. And you're going to have here. And then you're going to have a public here. Make sure you write that public with a colon. And then you're going to write the constructor. Remember, constructors are the same name. They don't have a return value. Constructors cannot have a return value, so don't put any return value here. You just write C flow mouse entity, C flow mouse entity, and you have to write this in exactly like this. So you have a C flow mouse entity for the constructor, and you're going to have to write S activation info, pointer, P act info. So you're going to have a pointer called P act info of type S activation info. And here on the constructor, when the flow graph is first made, when the flow graph is first initialized and it's made, obviously the constructor is run. The function of the constructor is run. Remember I told you that? That's what a constructor does. It runs the constructor once the object is made. So once the flow graph is loaded, once flow graph is instantiated, once it begins, once once it happens, right? When you create that flow graph, it runs a function. PActInfo, pgraph, set regularly updated, PActInfo, myID, true. You have to write it just exactly like that. What this does is it says my flow graph is going to update every frame. That's what that means. So when Whiteroom we create this flow graph, we're going to say this flow graph is going to be updated every single frame. That's why it's set to true. It is. It's going to be set regularly updated. Yes, it's going to be true. If you wanted to stop it from updating regularly, you would put false. But we do. Every single frame we want our flowgraph to be updated every frame. So that's what we do here. And then we make a destructor, cflow mouse entity, and we don't want to do anything in that destructor. We don't need to destruct anything, so we just leave that the way it is. We need these. All the stuff you see here, we do need. It's needed, otherwise you won't make your flowgraph properly. Void get memory usage is a function. iCrySizer. So you have a pointer pointer called S of type iCrySizer, and constant. That's a definition here. You need that. I don't know what it's for. Like I said, I like to say why I do things if I know, but honestly I don't know, so I can't tell you why. I'm not gonna lie. But you do need this. If I didn't include it last time, and it wouldn't run. I needed to include this, so you got to write that here just like that. Normally you'd have enumerations for the input ports, because this does not have any inputs. It doesn't. This node is not going to have any inputs. I don't need any input enumerations. If you did need input enumerations, you would just write the word enum. And you write the word, okay, you just do this. Enum, make an enumeration, and give it a name. See, E output ports. And this name can be whatever you want to call it. It's not specific. This is just what I decided to call mine. This can be called whatever you want to call it. E output ports, whatever you want to call it. So you make an enumeration, E output ports, okay? And you have to close it with a semicolon, and it's needed. Okay, so opening, and then closing with the semicolon. And then this is what this is. Very, very simple. Ready? EOP underscore activate. These are enumerations. And I'm not really sure on enumerations, but I do know this. EOP activate equals 0. And it's a list. It is a list. So you need these at the end. You need the comma, meaning it's separating. You need a comma at the end of every single one. It's a list. Parameter 1, parameter 2, parameter 3. So you need, you're separating the parameters. And you give only the first one a value. Only the first one. You can give it any value you want. But watch. Let me hover over this. Look at the last. EOP activate equals 0. Yeah, it does. What this means is from now on, that's going to equal 1. The second one's going to equal 2. That's going to equal 3. That's going to equal 4. That's going to equal 5. That's what's going to equal 6. That's it. You're basically making a list of 0, 1, 2, 3, 4, 5, 6, 7, 8. But you're just giving it a name. So EOP is going to be the first one in the list. EOP entity ID is going to be the second one in the list. 3D mouse position is going to be the third one in the list. That's all you're doing. You give the first one a value, and then every one will follow. Since this is 0, that's going to be 1. Look at the end. That's going to be 2. Look at the end. That's going to be 3. Look at the end. That's all you're doing. You're giving a numeric value a name. That's it. You're giving the 0 a name of EOP activate. You're giving EOP entity ID a value of 1. 3D mouse position a value of 2. You're giving 3 the value of said select. So that's all enumerations do. They just say you have 0, 1, 2, 3, 4, 5, 6, 7, blah, 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 right? And you're just giving a name. So that's going to equal 0, that's going to equal 1, this is going to equal 2, this is going to equal 3, this is going to equal 4, this is going to equal 5, and you're going to equal 6. You don't need these, but the enumerations, you honestly don't need those. But you'll see why I like to use these here. You'll see why. You don't need them, but you'll see why. And it may be confusing, but you'll see. It's not going to be confusing in a minute. We have to write virtual void get configuration, and it needs to be sflow node config. So we have the reference here, the address of config. I don't know how to say this, but sflow node config ampersand sign, and then config. And then you're going to define what the get configuration is going to do. This is where you define your inputs and outputs. I don't have any inputs, but this is where you put it. I don't have any inputs, but this is how you do it. Static, constant, S input port config inputs, and then it's an array. So opening and closing bracket equals. Then you'd have the opening and closing. Remember, you got to put the semicolon at the end. And then you'd go ahead in here and you'd put what your first input would be, what your second input would be, what your third input would be, what your fourth input would be, blah, 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 blah. But we don't have any inputs, so we don't use it. You know what I mean? We do have outputs, though, because we want this flow to have outputs, not inputs. So, in the get configuration function, we say static constant s output port config outputs. It's an array, so you need open and closing brackets, equals the first, and this is the syntax of this. This output port config is needed in every single time. Output port config, and output port config. This is the type of the port. It's really not that important, honestly. I don't think it is. I just think it's just helpful, honestly, a type. So you do need output port config. That needs to be there. Output port config. Those do need to be there. Output port config need to be there. Now what you see here is this underscore void is the type that it's going to output. You know in flowgraph they have the red symbols for int and the purple symbols for vector3. They have the green symbols for any or void. You know, that's what this is. This basically controls the color. You do need output port config, but what's inside these opening and closing greater than symbols here, this is what it's going to output. So this output here is going to output of type void. I mean, it's not going to output anything. It means it's just going to activate. It's going to be used as a trigger. You're not going to send any value out through it. You're just going to use a trigger. So you need to put output port config underscore void. That means that it's going to just output and it's not going to have anything. It will have a green symbol. Let's just put it that way. You know the ports have little colors? It's going to have a green symbol for void. Output port config, okay? And then what's inside here? Well, it's going to hold an entity ID. It means it's going to output an entity ID. Like I said, these are more visual, I believe. They're not really needed. But you do need to have something here. But the different types are not needed. You know, you can have them all void if you wanted to. They're just different. It's just helpful to put them what you're going to put out. So this one's going to have entity ID in here. Entity ID, meaning the port color is going to be red. This is going to be vector3, so the port color is going to be purple. So these are just controlling the port colors. So you put output port config, and then you put the type of port. The type of port is going to be vector3. This type of port is going to be of entity ID. This type of port is going to be void. Now you may be asking, why is these an open and closing bracket, open and closing greater than symbols, and this is not? This just says underscore void. That's because this is a special type of thing. Underscore void is a special type of one. Typically, they will be in this format. Output port config, opening, the type, closing. That's typical. That's typically what it is. Void is a special type, and they just don't include the opening here and then the closing. So you're going to need to put output port config underscore void, because it's not going to be any, it's not going to output any value. So it's going to be green, a green color port. Output port config entity ID is going to be a red port. And output port config vector3 is going to be a purple port. So we're going to have how many? 1, 2, and we end these obviously because it's a array. So it's a list. So we have to separate the different components with at the end of every one we have to separate it with a comma. So we have 3. We have 3 different ports. Outputs. Very, very important. See this opening curly bracket 0, closing curly bracket, and then this. This is needed. I don't know why, but you do need this at the end. It can't be in the beginning, or it needs to be at the end. The very, very end, you need this. Opening curly 0, closing curly, comma, and then you close that. So you do the same thing here for the outputs as you would do for the inputs. For the different type of inputs, but you don't have any inputs at all. You don't have any single inputs, so we don't need those. Instead, if you were, instead of using output port config, you use input port config up here. Okay, so now we said we have 3 different, 3, god damn it. Three different outputs, okay? Let's go over the structure, the syntax. So output port config, then you would have the type of the port, and this first, god damn it, this first parameter here is the name. So this port is going to be called activate. Second parameter, underscore help. This is going to be when you hover over that port, it's going to display this text. Outputs a trigger signal when we right click. There we go. So first parameter, name of the port. Second parameter, the help text. What's going to appear when you hover over it. Output port config, the type of port, name of the port is the first parameter, second parameter, the help text. Output port config, name of the port, type of the port, first parameter is the name of the port, second parameter the help text when you hover over the port. There we go. Now after that, you're going to just do a couple more things. If we had inputs, we would do this. Config dot p input ports equals inputs. P input ports equals inputs. Okay? We don't have any inputs, so we don't need it. We have outputs, so we do config dot p output ports equals outputs. Config dot s description equals help text, and then the help when you hover over the port. So these help texts are specific for the ports. I mean, when you hover over these specific ports, it outputs the help. This S description means when you hover over the actual node, the whole node itself, it'll output the help of the node. Config.setCategory, this is enumeration right here, and this means it's approved. You know how they have debug nodes, they have approved nodes, they have experimental work in progress nodes. You're just setting the category. I just set the category EFLN approved. Okay, if you want to see the different types of categories, you just right click on this, go to definition, and you're going to see it. Approved, advanced, debug, obsolete, category mask, uses mask core, unremovable, dynamic, these are the different flags it can have. Okay? Just like that. Okay, the get configuration is done. We've already named our inputs, told it we configured our output ports, give it a name, the help text, and told it what type the port's going to be. And we configured the outputs right here, finally. And we gave the whole node a description when we hover over it, and we set the category it's going to belong to. Now, get memory statistics. Get memory statistics here. You need this. Like I said, I don't know why, but it doesn't work if you don't include it. So go ahead. Exactly like this. Virtual void, get memory statistics. Pointer called S of type iCryesizer. And then it's going to add this. It's going to get the memory that this flow node is taking up. iFlow node pointer. Clone. Very important. This is one of the most offenders of not getting your flow nodes to work if you don't include this. Ready? iFlow node pointer, clone, S activation info, a pointer called pActInfo of type S activation info. Return new. Return new. Ready? Return new, and then this needs to be the name of your class. cFlow mouse entity. See, cFlow mouse entity. Whatever you name your class is going to be put into this return new of the iFlow node pointer clone. In the parentheses, it's going to be pActInfo. pActInfo. So it's going to be the name of your class and then pActInfo. Virtual void process event needs to be written exactly the same. It's actually an already existing function of flowgraph, flow system. It's just being overwritten by you. meaning you're overriding it. You're telling it what to do. Virtual void, process event. You need eFlow event, S activation info, P act info. Okay, pointer, P act info of type S activation info. Now what this process event does is it's in control of deciding when to output your ports, when to take inputs to your ports. This is the actual processing, the actual doer of the of your own class, your flow node class, the actual doer. And there's different types of events. There's different types of events here, and there's only two that we're going to be needing here. I recommend using the if you do not have any inputs, listen very carefully. If you do not have any inputs and you only have outputs, this EFI activate is going to be useless for you, because this is only happens when an input is received. That means when you input something, it'll call this will be the true, and it'll do whatever's in here. We only have outputs. Case EFE update. It's going to do this. Why is it going to do this? Because remember when we first made the flow array, when we first instantiate the flow graph, we told it to set regularly updated. It means it's going to update every frame. That means that this process event function is going to be called every frame with EFI update. Because we're updating it every frame, this is always going to be true. This EFI update is always going to be true. Always, always, always going to be true, because we told it to set regularly updated when we first created the node. So this is always going to activate. So you can be damn well sure that whatever is in this code will run every single frame or whenever the flow graph is updated. Okay? So I want to control when to output these, when to activate these outputs. When do I want to activate these outputs? So I do that. So every frame I decide when to activate outputs. Ready? Check if there is a valid entity selected, and if so, continue. If G entity ID under mouse does not equal 0, meaning, remember this is our entity, our global variable that holds our entity. So if we actually have an entity, if it's not 0, if we actually have an entity, then continue. Check if we right-clicked, and if so, then send mouse's 3D position and trigger signal. Okay? So we have a valid entity, let's continue. And did we right-click? Did we right-click? Well, how do we know if we right-clicked? Very simple. I made another global variable called right-click. Let's just scoot away from this flow graph for a minute. G right-clicked. How do we know if we right-clicked? Okay? So on RTS mouse, watch. You ready? Are you ready? When we right mouse button up, when we release, I made a global variable called G right clicked. Made a global variable extern bool G right clicked. Globals.cpp. I gave it a default value of false because we're not right clicking, so I give it a value of false. We don't include the extern. Remember, we don't include it on the CPP version. G right clicked equals false. Give it a default value. So when we right mouse button up, after we do everything, we go ahead and we say, okay, G left clicked is false, but G right clicked is true. That means our global variable will say yes, we just right clicked. So our global variable will equal true. G right click will equal true from now on. From now on, it knows that we right-clicked. Okay? It knows that we right-clicked. So, this is saying, do we have a valid entity? If we do, yes, continue. If we right-clicked, if G right-clicked equals true, which it does, G right-click does equal true, we do this. What do? We send entity ID on right-click as well as we send entity ID on right-click as well, as it appears that when they actually reach their destination, the AI goto node loses which entity is supposed to move. Don't worry about that. Anyways, when we right-click, so if right-click equals true, we want to activate output. That's the function. Activate output just like that. Activate output. The first parameter needs to be p_act_info. Straight and simple. That's what it needs to be, p_act_info. The second parameter, you ready? The second parameter needs to be EOP entity ID. EOP entity ID. This is what the port you want to activate. Then the value you want to send out that port. So very simple. Activate output activates the output port. Okay? Activate output activates an output port. It means it sends out a signal through one of the output ports. Hold on, guys. Hold on. Richie. What are you trying to climb for? You can't be climbing like that, buddy. Come here. Come here. I got you. It's a body.
What you climbing for? What you climbing for, huh? Let's go bring you out tomorrow.
All right, guys. Sorry about that. My son, my 1-year-old son, was trying to climb a chair, and he was getting stuck halfway up. So I had to get him and help him out. Anyways, so activate output means it's a function that activates an output. p_act_info is the first parameter. Second parameter is the output you want to activate, and the third parameter is the value you want to send out of that. See, isn't this the enumeration that we made? Isn't that one of the enumerations that we decided on what output we want to get? So EOP entity ID, that's one we want to activate. EOP entity ID, EOP entity ID. What does it equal? EOP entity ID equals 1, right? Because 0, 1, 2, 3, 4, 5, 6. So EOP entity ID equals 1. Equals 1. Very interesting. Okay, so we want to activate output 1. That's what it means. EOP equals 1. So we want to output activate 1. We could have written this. Bam. Very easy. Activate output, p_act_info. We want to activate output 1. And we want to send the value of this, entity ID under mouse, that global variable. But instead, we made it more user-friendly by putting EOP entity ID. That's all. The enumeration just makes things more user-friendly, readable. That's it. EOP underscore entity ID equals 1. As you saw. So we want to activate output 1. But what is output 1? What is output 1? We want to activate output 1 when we right-click. So when we right-click, we want to activate output 1. But what is it? Well, considering that this is how it works, the first one in the list is 0. The second one in the list is 1. The third one in the list is 2. The fourth one in the list is 3. The fifth one in the list is 4. You get what I'm saying? So this is output 0. This is output 1, because it starts at 0, not 1. This is output 0. This is output 1. This is output 2. So we said, hey, when you right-click, we want to output 1, which is this. We want to output the entity ID. We want to output that port. So every time the frame is updated, we check. Is there a valid entity selected? Yeah, there is, so go ahead and do it. Did we right-click? Because you only want to output when we right-click. Did we right-click? Yeah, we did, because that variable equals true, remember? So we activate it. So when we right-click, we resend out the entity ID from that port. So we resend out the entity ID from that port. See, global G entity ID under mouse holds the entity ID that we have. And it's not going to be 0 because we checked. Only if it's not 0. So it will output a valid entity ID. That's the value you want to output. It will output the entity ID. It will, what output it is, and then p_act_info. So when right-click, we want to do that. We also, after that, we want to activate output. We want to output the 3D mouse position port. We want to output the 3D mouse position port. Well, what's that one? 3D mouse position. What does that equal? 2. 0, 1, 2. Oh, we want to activate this port right here. Okay, that's awesome. So when we right-click, we want to activate the entity ID. So we want to send out the entity ID, and we want to send out the 3D position that we clicked on. It's cool. Because remember, the G right-click 3D position is the right-click position of where the mouse was when we clicked. So when we right-click, we send out the position of the entity. Okay. When we right-click, we also want to output the 3D position of the position of the mouse, and we also want to send out the activate, because we're going to be using this to go with the AI GoTo node, and I'm picturing what the ports on the AI GoTo node. There's a sync port, a cancel port, a position port, a place for where it to take what entity. Oh, okay. So when I right-click, I'm going to be using this with the AI GoTo node. So when I right-click, I want to resend out the entity that we currently have selected to make sure that it always knows what entity we're working on. So I re-output that. I want to send out the 3D position of the mouse when we right-click, and I also want to sync it because you want the AI to go when you right-click, right? So you left-click to select, right-click to go. So when I right-click, I want to send out the activate port, which is EOP. Activate, and I want to send a value of 1. Because this is void, I don't really send out a value, it just uses a trigger. I put a value of 1 because it's just really a trigger. So put a value of 1. So we did. When we right click, we send out the entity ID first. So the node always knows, no matter if we left right click, it always knows what we're talking about, what entity we actually want to use to move. We output the right click position, and in terms of AI GoTo node, it now knows what position we want to go to. And we also, finally, want to output this output, which we can use to sync. So when we right-click, we tell them to sync it means go. So when we right-click, we tell the AI GoTo node to start moving. What entity do we want to move? We already have that because we outputted this. We know the entity ID we know the entity we want to move. And the 3D position, we already know the 3D position because when we right-clicked, we sent out the 3D position. So now the AI GoTo node has every bit of information it needs. It knows the entity we want to move, what position we want to move it to, and when to move it when we right click, when to move. Cool. So that happens. And then at the very end, this is very important because you don't want your right click to be true permanently because we set it to be true. Remember we set the right click to be true when we right clicked, but we only want it to be true when we right click. We want it to go right back to false when we right click because when you right click, it's true. But when you let off the right-click button, it's not true anymore, is it? You're not right-clicking, right? Because when you right-click, we want to set the variable to true. Yes, we right-clicked. Then right after we did what you need to do, set it back to false because we're not right-clicking anymore. Because you're not. Unless you're holding down the right-click, then it's not going to be true all the time, correct? So when we right-click, we set it to true. And then immediately after we do what we need to do, we set it back to false. That's why I put this note here. Set back to false because we only want it true at the exact time we right click. So we take our right click value and we set it back to false. So in our RTS mouse, when it detected that we right clicked, we set the right click to true and the left click to false. And it immediately activates the outputs, and then we immediately turn it back to false again because we're not right clicking anymore. So okay. This updates every single time. So it's not going to activate this anymore because we're not right-clicking. I'm sorry. It's not going to activate this anymore because we're not right-clicking, right? If right-click equals true, it's not true. It's not true anymore because we set it back to false. So it's not going to do this. If G left-clicked equals true, see, when we left-click, we set left-click to true and right-click to false. You know what I'm saying? So when we left click, this will equal true. So if it is true, activate output, entity. We want to activate the entity ID output, and we want to send out the entity ID. So this is selecting. When we left click on something, we want to get the entity ID. We did, right? That's what we did before, and we assigned it to a global variable entity ID under mouse. We got it. So when we left click, we want to activate output, entity ID, and the value is our entity. So when we left click on something, we want to output this port right here, the entity ID, so that we can send that entity ID to the AI goto node. And then we set it back to false. Because on left clicking, we only want to get the entity ID and send it to the AI goto node so it knows what entity we're talking about. So very quickly, activate output. We have the first parameter, it has to be pActInfo. The second parameter is the port you want to activate. And the third parameter is the value you want to go out of that port. And then we're not left clicking anymore, so we set it right back to false. And then we go blah, 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 blah. Okay. This right here, we have register flow node, because in order to use it with the flowgraph system, you have to register it. And you just do it just like this. All caps. Register _ flow _ node. Opening and closing parentheses. Inside here, a string format. You put the section of the flow. You know when you right click on the flow graph editor, it gives you, right click, and you can like go here, go here, go here. And well, it's going to be part of the flow nodes group, colon, make sure you put the colon. It's going to be part of the flow nodes group. It's going to be part of the my flow nodes group, and the node is going to be called mouse entity. So that's what this is. So when you register your flow node, you tell it what group it's going to belong to by putting a name here, and you're going to tell it what the name of the flow node is going to be, mouse entity. And then the second parameter is the class, cFlow mouse entity. So the second parameter is cFlow mouse entity as the class. So when you register, you put the group, colon, the name of the node, and then you the name of the class. Pretty cool. So we've now gone ahead and we talked about how to detect movements by adding in our own enumerations. Detect mouse input. In the gamestartup.cpp, we said, okay, when we receive that input, go ahead and call a certain function. We talked about that, and it calls. We told it to call our mouse event function. So then we check. We told you how to check if using switch statements what event happened, if it was left mouse button down, left mouse button up, or if it was right button up. And then I told you how to do stuff based on if it's left mouse button, right mouse button, blah 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 blah. We talked about my raycast functions here to get the entity ID into the mouse. We talked about my function get right click 3D position. That instead of getting the entity ID, it gets the position of the ray hit, so we can move our person to that spot. We talked about storing a local variable into a global variable with the function, with these two here. And that's all. You should be able to, through this tutorial, be able to do right clicks, left clicks, and then tell your people to go by left clicking on the person and right clicking on a spot. Very, very simple. And let me just show you the flow graph, because you're going to need to know how to set up the flow graph. I hope I didn't mess anything up. So let me just build. God damn it. I knew it. You don't want to include WinUser in anything, by the way. Not a good idea. Let me just rebuild here. Okay, it succeeded. So I'm gonna save Cryengine game code only solution. Save all. Make sure everything's saved. Exit out. Open the editor up. Oh, I believe I also found out how to make my C++ work with the editor as well. I haven't done that yet, but I think I figured it out, so, which is pretty cool. And I think this is a long tutorial. I'm not sure how long I've been yapping my mouth, but yeah, I think it's been pretty long. Oh, God. I don't even know why C++ was giving me all the issues when I first started it. It was weird. Waiting on some internal blah, 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 blah. Oh, man, last night it did the same thing to me. It was crazy. Last night it kept saying, switch application, switch application. And it froze my whole freaking computer. I could move, but I couldn't switch anything. Every time I tried to click on something, it'd pop up saying, switch application. And it's like, Jesus fucking Christ, Visual Studio. You make my life harder. Anyways, oh, I got the new update. I'm pretty sure everybody does. The DirectX 11 update. I'll tell you what, though, when you program in C++, especially, let alone adding custom content, transferring from an old update to a new update is a fucking pain, man. It took me literally an hour just to transfer all my stuff over. Not the copying time, but C++, man. You know, I was so worried because it's like, okay, I modified some of the files that I didn't create myself. So if I, install the new update, what if they changed some of the C++ stuff and they added features to some of these C++ files from before? And then I try to override it with my files that I've modified myself. Now I don't have those new features anymore because I overridden it. So I'm so confused. And if somebody from Crytek is watching this video, I would like to put a tutorial up on how to officially transfer, migrating from an older version to a new version. Because if there's a certain way you're supposed to do it, please let me know. Because I don't want to lose any of my information, my hard work. I want to be able to get the latest of your updates to your technology, and I also want to use my stuff here. I don't want to have to because when I transfer my C++ stuff over, I'm overwriting files. And I don't want to overwrite a file that has updates to that file, and I lose all those. Please, if you guys have a migrating from one to another, please let me know a tutorial on that. Okay, I'm sorry. Go ahead and go to flowgraph. Entities, RTS game, and this is my flowgraph here. Right click, add node. See my flow nodes, remember that's the group we registered under, and then mouse entity was a name of it. There we go, see? The group, bam, and then mouse entity. See? And we have the activate, entity ID, and then the 3D position. We have 3 ports. Hover over the node, we'll see the help text, holds the entity ID of the currently selected entity, and outputs data based on mouse events. Hover over the activate port. See how it's green because we put void as a type. Entity ID is red because of the entity ID type we put, and this is purple because the vector 3 is purple. And the types you may need them. Like I told it to output a vector 3 value. Remember when we activate output function, we told it to output a vector 3 value. Maybe in order to output the vector 3 value, we do need that type to be vector 3. I'm not sure. I'm not sure if it's cosmetic to help you out here, or if you actually do need it. I'm not quite sure. So best stick to actually making the types what they actually output. Just stick to making. So if this doesn't output anything, make it void. If this outputs an integer or an entity ID, make sure you put the type to entity ID, just to avoid any issues. So let's hover over activate. Outputs a trigger signal when we right click. So when we right click, remember we told it to activate this, right? And we told it to, when we left click, output the entity ID. And also when we right click, output the entity ID, because there were some issues with that. When you told the AI to go somewhere and you didn't interrupt them and they actually reached their destination, if you try to right click again, expecting that he's going to move there, he won't. Because the node, AI GoTo node, basically deletes the entity ID after it's actually reached its destination. So when we right click to tell it to go somewhere else, we just make sure we re-output that entity ID. 3D mouse position. When you right click, we told it to output the 3D mouse position. And when we right click, we told it to activate. Very, very simple. So let me go and do this. I'll show you. Activate. So when we right click, we told it to sync. Remember? Right click, we activate. And sync means when we right click, go there. When we right click, go ahead and move. Sync. When we left click, go ahead and tell it what entity we want to move. When we right click, go ahead and tell it what entity we want to move. And when we right click, send out the 3D position. Pretty cool, huh? So when we right click, tell it what position to go to. We want to go to that right click position. And we want to go there. And this is the entity. Very, very simple. Pretty cool, huh? That's how you do it. Alright guys, thank you very much for staying through this long tutorial. I hope you guys enjoyed. And I hope you appreciate it. And please comment and let me know how I did, good or bad, doesn't matter. I do work hard on these tutorials. So please enjoy and let me know what you think, what you did. Thank you guys very, very much.